what we'll talk now about meshing. And with meshing, there's lots of changes of features and usabilities issues being addressed that I've got a significant number of slides now on meshing. So one of them is around orthogonal quality. We know how important it is to have a good mesh. And at 2021 R2, we introduced this ability to get more information about it. Even with a good orthogonal quality, though, you can still run into problems because there are some sorts of cells that orthogonal quality doesn't capture that are bad. So there's a new definition called enhanced orthogonal quality. So it's good because it handles high aspect ratio prismatic polyelements. So these are exactly the elements you get if you're doing a very fine wall mesh when you've got a polyhedral mesh. And so they're close to the wall, usually your low Y+ meshes. And if the quality's bad there, that's an issue. Previously, you might not detect that they were bad because of the metric. So what you have to do now for the moment is just issue this TUI command to yes, and it starts using this enhanced orthogonal quality. And when you send this mesh through to Fluent in the solver, it will continue to use that. So when you do look at quality or you monitor quality there, you will be using this enhanced value. I'm sure this is just a prelude to this becoming default. I suspect what's happening is they're looking to make sure this is capturing all the things they need it to. There's more support for wildcards in meshing tasks. So there's a couple of reasons for this, I guess. One is that you've got a lot of things to pick with a similar name. You can use this. But the other is, if you want to make your template that you generate or your script much more tolerant to changes in geometry, then by selecting via wildcards, you can always make sure that you pick up all the faces that belong to that particular group. So, you know, if you've got a whole pile of labels here, you can do things like anything that's got wheel in it, anything that ends WTL, something that has wheel at the start, so nothing before, wheel and front appears somewhere in it, and wheel and not the word tire. So this just picks up the wheel, front and rear, and rear and front. So it's very powerful for helping you set up objects now, like when you want to choose things for boundaries or mesh controls, etc. A couple of new sizing improvements. So it may be that you've got some thin regions here that you don't need proximity on, but you do want proximity on in other regions. So you can ignore the proximity in these thin regions by setting this parameter, refine thin regions to no. So those won't get proximity set, but there'll still be proximity between them. And then finally, when you've got things in, and maybe the shared topology hasn't done such a great job, and you've got two bodies here, and you've got a small, what appears like a small gap there, then you're getting a terrible amount of fine mesh here. Whereas if you say you want to ignore that across objects, you get the mesh you'd expect. So two very nice features. This is one that's again, that's really nice. It's akin to removing slithers. So if you bring in a mesh where there's obviously a CAD defect here, it was not intended, but it's a CAD defect, then you're going to have some small, highly skewed cells there. If you only improve the mesh, well, it gets a little better, but it doesn't go away. But if you do it down here in a surface mesh improved task, look, you've completely got around that. So the skewness has gone down enormously. So watch out for this. It can be used very effectively. Now, there's a new shared topology method going into here that it will connect edges of overlapping face pairs rather than doing a join intersect like it does now. And it's faster. It allows you to address cases that maybe you can't before. So if you're in space plane, you can go in here. When you do the share, you can create contact groups and they'll connect the topology, or you can go in and do it now directly with this new shared topology. So have a look at that. That's going to be useful. So those were all for the watertight meshing, which is what most people seem to use who've got reasonably clean CAD. They do a little bit of cleanup and they've got a nice system. That you'll notice if you turn on beta features that you can now have bodies where you don't have to have everything in one domain. So if you have to have shared topology across everything. You can have multiple fluids and solids and voids and that currently, but soon we'll have the released feature that you don't have to have shared meshes at certain interfaces. So I'm thinking of a rotating domain within a stationary domain. Lots of work is going to make this more flexible and adding these sorts of things in. So watch out for the mesher. It's also going to have the ability to have some swept regions in soon. That's active work. Now, if you've got really complex models or dirty CAD or things, then you're going to be bringing in a large set of CAD faces, or you might be bringing in sets of STL geometry. Object selection and setting is one big thing. So what this new features allows to do is to give you better ability to do that here. You can have some control over creating particular intersection loops. So you can pick some selected faces and create an intersection loop here if you want to absolutely make sure that that's captured. There's a lot of tools gone in for splitting prisms. So what this allows you to do is go in and generate a single prism layer and then split it, or take an existing set of prisms and do some splitting on them. So for example, if you want to refine them down closer to the wall, there's tools for doing that. Now, here's a couple of 3 blocks together. What you can do is add boundary layer to all zones. One layer, you set an aspect ratio. This is not going to split, so this just makes them. Then you can add a task where you want it to pick selected zones and split that into 5. So you split your 1 layer into 5 layers. And you may not like that as a mesh. You might want to change the aspect ratio or whatever. So you can go in and change that. And you can say don't split. So all you're doing now is changing the distribution of them. So this gives you a lot of flexibility, and you can see in this case, it's been done in such a manner that you go from thin to thick as a demo here, using different tasks. So this is a good way of actually getting some high quality inflation on. If you can't get lots of layers around, you might be able to get a couple around and then do splitting. There's a new way in the fault tolerant meshing of creating offsets surfaces or boxes. So the idea of this is that you might want to identify a region that you want to relate to either offsetting some geometry or building a box around a body, and that you can do now quite easily. So you could do an offset surface around this mirror. So why might you want to do things like this? Well, suppose you've got a mesh and you want to look at the impact of, say, 10 different wing mirrors here on a whole car. Do you really want to do the whole remeshing every time? What if you could put the mesh around this into a box and just swap that mesh in and out? And so that's the sort of thing you can do here. You could replace, for example, this spoiler by having a region defined around it. You can bring the mesh in. Now, you can then go in and you can just update the volume mesh, or you could go and update the surface mesh around this area too, depending on what you want to do.